Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to invite all our members into our discussion for today, and we are going to look at a special case of finding limits using what we refer to as the L'Hopital's rule. Now, this is going to be one of the rules that is going to be coming up with a way of trying to find or finding rather limits for what we refer to as indeterminate forms of particular equations. Now, in a sense, we have looked at various methods in our previous discussion of evaluating limits, and one of the methods is substitution methods, which of course I had just mentioned in one of our videos. Basically, we have done some of the videos in trying to find limits of some of the functions which we have basically looked at concerning the concept of a limit. Now, these are some of the three methods which we had basically employed in trying to find limits. Now, there are some instances whereby these specific methods are not going to be assisting us to find the specific limits or are going to be proving useful. Now, this is because there are some of the expressions which equations which we are going to come across which are going to be, of course, referred to as indeterminate forms. And these indeterminate forms are not going to be proving difficult for us in employing either of these specific methods in finding the results for their limit. Now, a French, of course, mathematician by the name Rolle de L'Hopital. I hope my pronunciation is correct. So this French mathematician by the name Rolle de L'Hopital came up with a form of trying to find the results for this indeterminate form of the equations. And we're going to see that his work basically provided a way in which we can evaluate for equations of the forms which we are going to regard to as indeterminate forms. And we're going to basically try to define this specific concept of the L'Hopital's rule using perhaps a statement form, whereby we are going to have this specific statement. So I'm going to put this specific rule in a statement form, which is going to be assisting us try to, of course, understand the basic application of this particular rule for the determinate form of this particular, of course, equations. So in a sense, if the limit, if the limit of course, an equation as x tends to c of a function fx all over tx, of course, is going to, or is results in any of the following forms. So if the limit of a function fx over gx as x tends to c result in any of the following forms, whereby we're going to have either 0 over 0, or positive or negative infinity over infinity, or we're going to have this one still resulting in a form of 0 times a positive or negative infinity, or in a form of infinity minus infinity, or in a form of 0 raised to 0, or infinity raised to 0, or in a form of 1 raised to infinity. And as the limit of this specific function as x tends to c of f prime of x all over g prime over x, of course, exists, and g prime over x is not equivalent to 0, we're going to see that we can find this specific aspect of the limit for these particular functions or these forms of functions by using the L'Hopital's rule, which states that then the limit as x tends to c of a function fx all over g of x is equivalent to the limit as x tends to c over f prime over x all over g prime of x, given as that. So this is going to be giving us a sum of particularly the expression for the L'Hopital's rule, which is going to culminate from this specific statement, which we have said that if the limit of a function as x tends to c of a function fx over g of x, this of course is going to be a rational form, results in n of these particular forms which we have given in terms of 0 over 0, plus or minus infinity over infinity, 0 times positive or negative infinity, infinity minus infinity, 0 raised to 0, infinity raised to 0, 1 raised to infinity, and that the first derivative of this specific form of a rational function was the limit of x tends to c over f prime x over g prime over x exists, and that the denominator of this specific derivative is not equivalent to 0, then it's in order for us to have the limit as x tends to c over function fx over g of x given as the limit over x x tends to c over f prime over g prime given as that. And this is going to be giving us a sum of what we refer to as the L'Hopital's rule. And this is going to be assisting us trying to define perhaps or rather limits for these different following forms of limits which we're going to have on the board. Now, in a sense, then therefore it's going to be providing an alternative method for trying to solve limits from the previous methods of substitution, factoring, and conjugate method, which are listed in my opening statement. And this is going to be, of course, assisting us in trying to find the various ways of finding these specific limits. So kindly check our description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for updates in different discussion we're going to do in math and sciences. So that is it for now, guys. By God bless you. Catch us in our next video.